Welcome to this explainer, everyone. Now, if you're a C-suite leader or a strategist, listen up, because this one is absolutely for you. We're looking at a massive fundamental shift happening in the industry right now. We are moving away from rigid, programmed automation and stepping into the era of adaptive, intelligent robotic systems. Let's dive straight into the source material and figure out how enterprise infrastructure is shifting from systems that just blindly execute commands to systems that actually learn, and more importantly, what that means for your bottom line.
So here's our game plan for today. First up, robot anatomy and mechatronics. Then we'll look at the AI revolution and evolution. Third is the digital brain and senses. And finally, we'll wrap up with strategic smart robot applications.
Okay, let's actually rewind all the way back to 1950. Alan Turing asked a deceptively simple question: can machines think? It wasn't just a fun philosophical thought experiment. It literally set the strategic endpoint that we are still chasing today. It's the origin point of moving beyond just basic computation and into actual machine cognition. All right, part one, robot anatomy and mechatronics.
It's kind of fascinating how mechatronics completely mirrors our own biology, right? Think of a traditional robot just like human anatomy. You've got the microcontrollers acting as the brain, making the core decisions. Then you have sensors acting as the senses, gathering data from the outside world. And finally, the actuators are the muscles, physically executing the movement. It's this really beautiful art of fusing these three elements together to build functional machines. And these biological parts? They create a continuous, infinite loop that we call the robot cycle. First, it senses the environment. Next, the microcontroller processes that data. And finally, it acts by sending an electrical command right to the motors. Sense, process, act, over and over again. But, and this is a big but, here is the massive strategic vulnerability for your operations: interdependence risk. With these traditional systems, if just one piece of the puzzle fails, the whole system literally collapses. No sensor, the robot is totally blind and just smashes into a wall. No processor, it's a body with no mind. No actuators, it's paralyzed. In a traditional factory setting, this rigidity means a single point to failure stops your entire production line dead in its tracks.
Which brings us to Section 2, the AI revolution and evolution. Now, you might be thinking AI just popped up overnight, but it is absolutely not a sudden fad. It is a deeply mature compounding technology. Look at this. From its birth back in 1956, to basic machine learning in the 60s, to that massive deep learning explosion in the 2010s that finally gave us self-driving cars. And now, we are fully in the 2020s, the era of giant models. What we're looking at is a massive compounding curve of capability.
So, what does this actually look like in the real world? Well, take a traditional robot, like one of those older automated vacuums. It merely executes fixed, pre-programmed if-then commands. It hits a couch, turns, and just repeats the exact same inefficient path. But an AI-driven robot, it actually understands. It learns the layout of the room, maps out obstacles, and dynamically adapts on the fly. That right there is the strategic pivot, moving from blind, rigid execution to intelligent, dynamic adaptation. Moving right along to Section 3, the digital brain and senses. This whole shift really kicks off with machine learning. Instead of having some engineer manually type out endless lines of code for every possible scenario a machine might face, the machine is just fed massive, massive amounts of data. It trains its own mathematical models to recognize patterns, predict outcomes, and actually make autonomous decisions. It literally learns from experience, much like a new human employee would. And building right on top of that foundation, we have deep learning. This is where capabilities just totally explode. By mimicking the actual neural architecture of the human brain, deep learning can handle incredibly messy, unstructured data that traditional software simply can't touch. I'm talking about things like nuanced audio, raw text, and live, complex video streams. One of the absolute coolest results of this is natural language processing, or NLP. Basically, this acts as the machine's voice and ears. It grants these systems the power to instantly analyze spoken or written words, grasp the context, and generate incredibly human-like responses. It completely shatters the old communication barrier between us and our machines. Then we've got computer vision. This literally gives your automated machines digital eyes. The system can look at a live video feed, extract key features, and make instant decisions. Talk about an enterprise game changer. It's exactly what lets a self-driving car spot a pedestrian darting into the street, or a factory system detect a microscopic product defect without ever having to stop the assembly line.
All right, let's bring it all together in Section 4, Strategic Smart Robot Applications.
When we look at manufacturing, AI robotics are completely redefining productivity in smart factories. And we aren't just talking about making things faster. We're talking about vision-equipped robotic arms working relentless, 24/7 schedules with microscopic precision. They're stepping in to take over dangerous, hazardous tasks to improve worker safety. And they perform real-time quality control that drastically cuts down on error rates and material waste right there on the production floor.
And if we pivot over to healthcare, AI robotics are quite literally saving lives and revolutionizing patient outcomes. A perfect example of this is the Da Vinci surgical robot. It assists human surgeons in executing incredibly complex procedures with a level of hyper-accuracy that human hands alone just cannot match. And that precision, it directly translates to lower infection risks and significantly faster recovery times for the patients.
Finally, just look at the sheer scale of intelligent agriculture. In an industry defined by massive plots of land and super tight margins, autonomous drones are absolute game changers. They map the farms, use computer vision to spot crop diseases early on, and perform hyper-precision spraying. It totally optimizes resource use, lowers costs, and drastically improves both the speed and the yield quality of the harvest. So, as we wrap up this explainer, I really want to leave you with a thought directly from our sources. The future is not just programmed, it is learned. Look, AI and robotics, they are no longer theoretical whiteboard concepts. They are the actual tools that will dictate the market victors of tomorrow. So, as your enterprise scales, I challenge you to ask yourself, are you just building a rigid infrastructure that blindly follows commands? Or are you investing in an intelligent system built to learn, adapt, and evolve?